Assalamu alaikum wa rahmatullahi wa barakatuh. My dear brothers and sisters, welcome to the lecture 2. In our previous lecture, we discussed the introductory of algorithm. We discussed the definition of algorithm. We discussed the difference between algorithm and program, where we look at some differences, where I stated some differences like algorithm. I said it is being designed at the design phase in software development life cycle. Then program is being created or is being developed using at the stage of implementation, that is using programming language. And I stated that algorithm is created by someone who has a domain knowledge. For example, a doctor is going to create the algorithm, for example, or use a software developer. You are going to consult the doctor in order to create a software that will suit medical field. You understand? For example, you want to create a live sporting system. You are not going to, you don't know how the medical people took their job. You understand? So you are going to do a system analysis and design to critically detect their needs. Then you are going to implement it into the software aspect. So after that, we see and the program is designed by the programmer. Let me show you. There is one course, system analysis and design. This course deals with the critical investigation of the system needs. For example, when you want to create software in any field, as you know, we software developers, we work in every field of life, like medical field, business, educational, any sector in life. You understand? So for we to create anything regarding that aspect or that field, we have to investigate to find how that thing or this concept work in this field. So for example, for you to create something or like life supporting system in hospital, you must consult doctor. So in the process of a design algorithm, you are going to consult doctor how for example, if you are creating software in the medical field. So but the programmer, after you created the algorithm, with the help of the a doctor or someone who has knowledge in medical field, if you are creating software in medical field, then the programmer will translate that requirement into the software, into the product. So this is just a little about what we discussed in previous lecture, that is lecture 1. If you don't get that one, go back and watch, because we are going to create a playlist where each lecture has relationship its previous or succeeded. You understand? So don't skip anyone. So today we are going to discuss about interesting part of algorithm, that is characteristics of algorithm. Characteristics of algorithm. When we say characteristics, we mean that the features, because algorithm is a step-by-step procedure of solving a problem. So when you see any procedure of instruction, there are some criteria and conditions that a procedure of instruction must fulfill before it is called algorithm. So the first one is input. Every algorithm must have an input. An input is, for example, you want to go to your house, so a person wants go to your house, you say, take this road. Take this road is an input. You are telling him this is the first step. So it's the is the input. Then second, output. At the end of every algorithm, we must have output. If not, this is not algorithm, because at the definition I stated that algorithm is a step-by-step procedure or process of solving a problem. Another characteristic, we have finite. Algorithm must be finite. For example, it must stop at the end when you reach where you want to go. For example, your brain want to find your house. When you guide him by giving him address, when he go to this street, turn right, turn left. When he see mosque or masjid, go there. You understand? When you reach the end of the street, he stopped, and your house is facing a school. You understand? So, what I want you to understand, algorithm must be finite, and it must stop at the end because you want to achieve some goals. So this and the first one is effectiveness. 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 Algorithm must be very effective in such a way that even a person who couldn't understand, a layman can understand what you write, you understand, or you address, because you as a software programmer or someone creating or developing algorithm, you are communicating with the dullest thing ever, that is computer. Computer couldn't think it. You are the one instructing it to do anything that computer does. You understand? It is the capability and the ability of man to make it do that. So a computer also just understands 0 and 1. So you, the programmer, you are the one to make the computer to function well. So it's we have seen how to investigate the characteristics of algorithm. So today, now we are going to see how to compare, to write the algorithm and compare it with the input, its characteristic, the output, its characteristic, and all the other characteristic. So for example, the way we are writing algorithm, for example, let's say I call maybe I write a function which is called swap. I gave it two input A and B. The action that I want this algorithm to do is to take the value of A and B and to swap them, that is to exchange the value. If one is the value of A, B, 2 is the value of B, so I want write a procedure and instruction that tells the computer that take the value of B and exchange it with the value of A. So this is the algorithm I'm going to create. So I call the function swap. I gave it uh, A and B as an input. And remember, in the characteristic of algorithm, I will say characteristic number one, it must have an input. So A and B is our what? Our input. Then I will start demonstrating how it will swap the, I will give it instruction how to what, how to swap the value of A and B. Then I will say I will create a variable. A variable is a placeholder that holds the value of whatever you assign to it. Temp A equals to A. I say take the value of take the value of A to be temp. So this is a variable. Then I will say A is equals to B. I assign the value of A equals to B. I'm going to elaborate. Don't be confused. Inshallah. Then I will say B is equals to temp. Okay. So this is the end of the instruction. So look at here. I say among the characteristic of algorithm, it must be it must have input. Second, it must have output. Then it should be effective. Then it should be finite. For number two, three, finite, and number four, effectiveness. Effectiveness. You understand? So let's say if this algorithm fulfilled all the criteria and condition of this algorithm design methodology or procedures. So A and B are input. So A and B are input, correct? Output. So suppose A, let me, for example, when I write the program, let me say A is equals to 2, B is equals to 3. So here at the instruction, I'm telling the computer temp equals to A. What is the value of A here is 2. So now it's stored the temp as A. Then A equals to B. What is the value of B here? So this one is another variable. So it will say B is equals to 3 and A is equals to 3. Then B is equals to temp. What is the value of temp is 2. This is 2. So at the end, you see here initially we have A, B, and the value is 2, 3. But when at the end we will get A is equals to 3 and B is equals to 2, which is the reciprocal, or I say is swapped value of what I want initially create. For example, A, you see I have 2 here, but when I go here, for example, you see the value of A, which I assign it now to be 3. You understand? Then B, what is the value of B? Now it changed to this one, which I said it is now 2. So you see, the value of A here is has changed. The value of 3 here, B is here is 2. So that is why this one, and the end result is I will get the swap value. So it's fulfill this criteria, and finite its end. So it also fulfilled. At the end, it will stop. Effectiveness, as I elaborate and explain, you understand what it means. So it is very effective. So this is how we create algorithm. I hope you enjoy. uh, if you don't understand, please uh, let me know at the comment section. Thank you.